Unit 1, Objective 2, Notes, Day 1. We're going to start with a little bit of review. Level 1 is review, and the review is topics we have already worked on in previous objectives. So we'll start with the first one, simplify the following. We're using our rules of exponents, and so that means we're going to raise each part of that term to the third power. So that would be -2 to the third power, x to the -3 to the third power, y to the 5th to the third power. When we simplify, that's -8, x to the -9, y to the 15th. And then the second rule of exponents is any negative powers move to the denominator. So -8y to the 15th over x to the 9. 1b is using our conjugate rule when we're dividing with radicals. So we're going to multiply by 1 plus root 2 over 1 plus root 2. I will put parentheses around those because it helps me to remember to distribute. So that's going to distribute the 3 in the numerator. So that's going to be 3 plus 3 root 2. In the denominator, we either use double distributing or we use FOIL, whatever you learned in Algebra 1. So 1 times 1 is 1 plus root 2 minus root 2 and then minus root 4. These two terms, when we're multiplying with conjugates, will always subtract away to 0. Root 4 is 2. 1 subtract 2 is -1. So we've got 3 plus 3 root 2 over -1. Then we divide. So we're going to take 3 divided by -1 plus 3 root 2 divided by -1. So we're going to apply that denominator to each term in the numerator. And so we end up with -3 minus 3 root 2. 1c is multiplying, which was objective 1. So when we multiply 20 times 6, we get the square root of 120. And then we factor 120 into the largest perfect square factor times the remaining factor. So you would go through your perfect square factors, finding that 4 divides into 120 30 times. Root 4 is 2, so 2 root 30. 1d, this was rationalizing from our last objective. We're going to multiply by root 2 over root 2. And when we multiply across the top, we're going to get 12 root 2. And when we multiply across the bottom, we're going to get root 4. Root 4 simplifies to 2. Now both the 2 and the 12 are outside. So 6 root 2 is my answer. 1e, when you're dividing with radicals and you have two numbers that are both underneath the radical symbol, you can divide them if one is a factor of the other. So 10 does divide into 120 12 times, and by doing so, you've now removed the radical from the denominator. So what we're looking at is radical 12, or root 12 in the numerator, and 5 in the denominator. So there is no rationalizing here because you don't have a radical anymore in the denominator. But you will simplify root 12, and that becomes 2 root 3 over 5. So remember, root 12 is root 4 times root 3. Last review, and again, this similar to the previous example, when you have a fraction inside a radical, you should always try to reduce the fraction first. 4 does divide into 32 8 times. This gives me root 8 because the 4 becomes 1, and that simplifies to root 4 times root 2, which is 2 root 2. All right, so that is a review of Unit P for the exponents, and the rest was a review of Objective 1. Down here we have some multiplying binomials, also good review. This is called multiplying binomials, and what's inside those binomials can be any kinds of terms. In 2A, we just have regular variables and numbers. So again, I'm going to remind you to either use FOIL or double distributing. 2x times 3x, 6x squared, minus 10x, plus 27x, minus 45. Combining your like terms, 6x squared plus 17x minus 45. For the next one, I'm going to have you pause and do the problem, and then you're going to submit your answer into the Edpuzzle blank. So that's going to give us 16 minus 12 root 2 plus 12 root 2 minus 9 root 4. These zero out. 16 minus 18 is a negative 2. And so that should have been the answer that you put in the blank in Edpuzzle. Okay, now we're going to get into our new objective, which is simplifying square roots when we have variables under the square root. And for the day one notes, all of our variables are going to have even exponents. When you simplify the square root of a variable that is raised to an even power, we begin by thinking about what would it look like if we expanded the variable under the square root. So if we expand the square root of a squared, it becomes the square root of a times a. Now we remember when we have a pair of numbers or a pair of the same variables, one of those variables comes out or one of those numbers comes out. So to remind you, when we are doing the square root of 25, we are thinking of it as the square root of 5 times 5, which is just 5. So that's what it looks like numerically. The square root of a to the fourth would expand to the square root of a times a times a times a. So now I have one pair of a's, but I also have a second pair of a's. So that means two of those a's will come out, but instead of adding them, we multiply them. So it will come out as a squared. When you simplify square roots with variables, you want to find pairs of variables. The number of pairs tells you the variable's exponent when you remove the square root. So if you go back up to the square root of a to the fourth, you see that there was one pair of a's and a second pair of a's, and so the exponent on a when you remove the root is 2. All right, so the square root of a squared. So we'll start with that first example. So I'm going to let you try it and pause, and then you can put the answer in the blank in Edpuzzle. So the square root of x squared is x, because when you expand it, that's the square root of x times x, one pair, so 1x comes out. For b, we have the square root, and again 4 a's, because it's a to the fourth, and 2 b's. Here's one pair, here's a second pair. So that means the exponent on a is 2, one pair of b's, 1b comes out. I'm going to let you go ahead and try C on your own, and you can put your answer in Edpuzzle. So this is going to be 3, because the square root of 9 is 3. And then when you expand the r, you're going to have 6 of them. 1, 2, 3, 4, 5, 6. There's one pair, there's a second pair, there's a third pair. So 3r to the third. D, we have 6, a to the 6th, and b to the 10th. So if we were to write them all out, we are thinking about how many pairs there are in 6 a's and how many pairs there are in 10 b's. Now instead of writing them all out, a shortcut is for you to take that exponent and divide it by 2 because 2 represents a pair. So square root of a to the 6th would be a to the 3rd. Square root of b to the 10th would be b to the 5th. There are 5 pairs of b's when you expand and write out 10. 3e, the square root of 16 is 4. That's a perfect square. The square root of x squared, or excuse me, x to the 4th, x squared. Square root of y to the 20th, y to the 10th. Similar to what we did in D. So there are 10 pairs of y's. Square root of 40x to the 40. Well, square root of 40 is not a perfect square, and so we follow the process that we did in Unit P. We break down the square root into 4 times 10, so that's going to be a 2, but I'm going to have a remaining 10 inside the radical. X to the 40, 40 is even, divide by 2, x to the 20. G, root 75. That is not a perfect square, and so we determine the largest perfect square that divides into 75. So that's root 25 and root 3. Now that root 25 simplifies to 5. The 5 is going to multiply the existing 2, and that gives me 10. Root x to the 4th, square root x to the 4th is x squared, and I have a root 3 remaining under the radical. All right, you try. So for the you try, I'm going to let you do the first one again, and then you can put your answer in Edpuzzle. And so the square root of x squared y squared is xy. Now for the rest of these, again, you should pause, try them, and then you can check in again with me for the answer. So for B, root a to the 6th is a cubed. For C, I'm going to have you again input your answer into Edpuzzle, and then you can check. So root 4r squared is 2r. For D, root 9 is 3, multiplies the existing 2, that's 6. A to the 8th becomes a to the 4th. So again, the shortcut is to just divide that exponent by 2 because you're looking for pairs. B to the 6th becomes b to the 3rd when you square root it. For E, we have an x and a y outside of the radical. So whatever comes out will multiply the x and the y. Root 98, you need to find the largest perfect square that divides into 98. So root 49, root 2, you can take your calculator and go through the perfect squares. So take 98 and divide 4, 9, 16, 25, 36 until you have the largest perfect square that divides into 98. So that's root 49 and root 2. Root 49 is 7. So now we know a 7 is going to come out. But we know that there's going to be a root 2 remaining inside. Root x to the 6th, that's 3 pairs, so that's x to the 3rd. There was already an x there, so that's x to the 4th. So you're going to multiply x to the 3rd times x is x to the 4th. Y squared, when you root it, you get y. There's already a y there. So when you multiply it, you get y squared. Last one. We have root 44, so that's root 4 times root 11. Again, largest perfect square that divides into 44. Root 4 is 2, multiplies the negative 4. It's going to give me negative 8. We do know that there will be a root 11 left inside. X to the 4th roots to x squared. There's already an x to the 4th. So if you think about it, x to the 4th times x squared, now we're using the rules of exponents from Unit P. So that's x to the 6th. Y to the 44th, that means there's 22 pairs. So that's y to the 22. There's already a y, so y to the 22 times y is going to give me y to the 23. And that is the end of day 1 notes.